output, or we just go straight to the creative part?
Let's start from the beginning.
From the beginning, no, I feel from the beginning, I just, I feel you already understand.
Let's know what his beginning looks like.
Okay.
Some of us didn't meet the beginning.
Yes.
Now, if you are talking about an economy is made up of different sectors. Those that in Nigeria now, we have the agricultural sector, we have the manufacturing sector, and the tertiary sector. So now, the concept of input-output analysis explains how these sectors, this one depends on the other one depends on the other one. That is, the output of another sector is used as the input of another sector in the production process. And that's why I say that input-output analysis is a quantitative economic technique used to examine the interdependency that exists among different sectors in an economy. So that relationship that exists among different sectors in an economy, it is what we use the input-output technique to analyze, or to investigate, or to examine that relationship that exists. And they say that the technique was developed by a Russian American economist. That is Wassily Leontief. That is the name of the person. Wassily Leontief. He was the person that brought about the input-output technique as a usage of examining the relationship, the interdependence that exists between different sectors in an economy. Now the theory is, the technique is based on several assumptions. The technique is based on several assumptions. Assumption number one is that there is fixed technology in production. That is fixed technical coefficient. That is, each industry uses input in fixed proportion. The production of goods that can be used as input of another industry. That is, in the production, a particular industry uses a fixed level of input. That is, a technology being applied to is being fixed. That is assumption number one. That each industry uses input in fixed proportions to produce 1 unit of output. There is no substitution between inputs. That is, you cannot substitute labor and capital. They are fixed. That is assumption number one for input-output analysis. Assumption number two is that there is constant return to scale. Constant returns to scale. That is, output changes in the same proportion as input. If input is changing at the proportion of 50%, output, no, you can talk about output, yes, output too can change in the proportion of 50%. That is constant returns to scale. Output changes in the same proportion as input. Now, assumption number three is that there is homogeneous output. Each industry produces only one standard product, and all units of that product are identical in quality. What industry A is producing is identical to industry B. What industry C is producing is identical to industry B and A in that order. That is the third assumption. And the fourth assumption is there is no supply constraint. Industries can produce any level of output required to meet demand, assuming sufficient inputs are available. There is no limitation in terms of their supply policies. That is for input-output analysis to hold in any economy. The supply channels will not be limited. There will be no constraints in terms of supply, so that the output of a particular sector can flow smoothly to be used as input in another sector. So if there are limitations in terms of supply, then input-output analysis will not hold. Then we have different components of this input-output analysis. So this input analysis, component number one is intermediate demand, or intermediate transactions, or inter-industry transactions. The relationship that exists between these industries in terms of sharing their input and output. Now, you see that intermediate demand or intermediate transactions or inter-industry transactions represent a purchase access of goods and services among industries. A particular industry will purchase the output of another industry and use the output of that industry as input in his or her industry in terms of production. So that process of purchasing the input of the output of another industry and using it as an input in your own industry is called intermediate demand. So intermediate transactions, so inter-industry transactions. Another component of this input-output analysis is the final demand. Now, final demand consists of goods and services purchased for final usage rather than for consumption. Because during production process, a particular company or industry can purchase the output from another company and use that output in production. After production, that output will be sold to final consumers. The final consumers are not purchasing it to go and use in production again. Because if you purchase a car from an automobile company, you are not using that car to produce another thing instead. You are consuming it in your own usage. You are rendering services for your personal consumption as for your comfort. So that aspect of consumers purchasing the output of another company for their usage, that aspect of input-output analysis is called the final demand. And there is another one, the primary input or the value added. These are inputs that are originated outside the production sector, and they include labor, wages, and salaries. Another aspect of this input-output analysis is the total output. The total output or gross output. And when you have total output, you also have total input. And for this input analysis, when you get to that table, you will discover that the total output and the total input must be equal. Now, the total output can also be referred to as the gross output, total input, or gross input, essentially. Now, the total output or gross output is the addition of the intermediate demand plus the final demand. When you add your final demand and the demand for goods and services in production process together, what you have is a total output. That's why they say that the total output is the sum of intermediate demand and the final demand for each sector. When you add the final demand plus the intermediate demand together, you have the total output or the gross output. And there is another part of this input-output analysis that is called the technical coefficient, or the matrix of technical coefficient. That one is represented with capital letter A. It's called the matrix of technical coefficient, and it shows the amount of input required from another sector to produce 1 unit of output in another sector. That matrix that shows that this is the quantity or this is the proportion of input that you are supposed to get from this sector for you to produce your own output. That matrix that contains such coefficient is called technical coefficient or matrix of technical values or technological coefficient. It shows that for you to produce 1 unit of output in your own industry, you must get this proportion of input from this other industry, or from this other sector, for you to produce 1 unit of output in your own sector. So that matrix that contains such coefficient is called the technical coefficient matrix or technological coefficient matrix. We also have the Leontief matrix. Now that Leontief matrix is a subtraction of an identity matrix from the technical coefficient. Because we say that the technical matrix or technical coefficient should be represented with capital letter A. Then an identity matrix is capital letter R. So if it is an identity matrix for a 2 by 2 matrix, that is a square matrix, then you have 2 rows. This is 1 row, the second row. Then an identity matrix is a matrix where all the elements on the major diagonal, like this, are made up of 1, 1. Then the remaining elements are zeros. It's an identity matrix. Then that part of the input-output analysis that is called the Leontief matrix is the difference of identity matrix and the technical coefficient matrix. When you subtract the technical coefficient matrix from the identity matrix, you have the Leontief matrix. Leontief matrix. Why this one is the matrix of technical coefficient? Technical coefficient. Then this one here is the identity matrix. Identity matrix. So when you have a problem that your identity matrix will be a 3 by 3 matrix, instead of having row 1, row 2, column 1, column 2, we have for 3 by 3 matrix, we have the first row 1 0 0 0 1 0 0 0 1. Because since we are dealing with an identity matrix, all the elements on the major diagonal here must be 1, and the remaining elements will be 0. So this one is for 3 by 3 matrix. So they will give you a question that involves either a question that has to do with two unknowns, x1, x2, or x1, x2, and x3, depending on the requirement. Then if you will choose a particular identity matrix to use, either a 3 by 3 identity matrix for 3 unknowns or 2 unknowns. Then another part of the input output analysis is an input output table. Now that input output table comprises of all the components that I have mentioned. The input output analysis table comprises of all the components. It comprises of the intermediate demand and the final demand, the gross output or total output, and the primary value or the primary input or the value added. So the input output table is a summary of all the components in input output analysis. So they will give you a question that will involve you to find the technical coefficient, because before you solve anything further for this input output analysis, you must first of all derive the technical coefficient first. And after getting the technical coefficient, you form this matrix. And for you to form this matrix, you must take the difference between the identity matrix and the technical coefficient matrix. Then from there you find the inverse. Then you multiply by the final demand. So let's take a sample of the input output table. Yeah, it's all an example. So you have sectors here. You have sectors here. This one should be sector 1, sector 1, sector 2. Then this one should be intermediate demand. Intermediate demand. And this one should be final demand. This one should be total output. Total output can be written as gross output. This one is sector 1. Sector 2. now, let's just assume hypothetical let us represent this one before we use an example that has to do with numbers. We saw how many examples in class?
Up to like 3 or 4.
3 or 4. So let's say this one is the row 1, column 1, row 2, column 2. Then this one is the value added. Now for row 1, let's say A. Now we're using A to represent a technical coefficient. This is row 1. Row 1. Here is column 1. 1, 1. Here, still on row 1. Column 2. Row 1. But this one here is not a sector. Another sector. Still, this one is row 2. Column 1. Row 2. Column 2. Now, the intermediate demand here is the sum of these two. Intermediate demand here is the sum of A1, 1 plus A1, 2. If you add these two, you will have intermediate demand. If you add these two here, A21 plus A22, you give you intermediate demand. Now, the final demand here, when you add this one and you subtract this one from the total output, what you have is the final demand. So in a question, you may either be given the total output or the final demand. Because when you have the final demand, you can get the total output. Because the total output now is the sum of the intermediate demand and the final demand. So let's say the final demand should be D. And the final demand, now this one here is sector 1. The final demand for sector 1 will be D1. The final demand for sector 2 will be D2. Now, when you have something of this nature, you can easily get the total output. The total output now is the final demand plus the intermediate demand. Then you have A1, 1 plus A1, 2 plus D1. Will give you the total output there. Then here is A21 plus A22 plus D2. Will give you the total output there. And the same thing applicable to this one. When you add this one and this one together, you will get a value added for sector 1. When you add this one and this one together, you will get a value added for sector 2. So the sector 1, sector 2, sector 1, sector 2. So when you add A1 plus A21, you have the value added for sector 1. When you add the A12 plus A22, A12 plus A22, you get the value added here. Now, when you add the total input here for sector 1 is supposed to be equal to the total input for sector 1 here. No?
Total input here.
Yes.
Output here.
Yes, that's supposed to be equal because it's the same sectors. One here, look at sector 1, the total input. Look at sector 1, the total input. So once you have this one is supposed to be equal to what you have here. So in essence, when you don't have this one, and you have this one, it's just this one minus this. Then you have what is here. Because it's supposed to be equal. Look, it's sector 1. Sector 1. So the total output here for this sector 1 is going to be equal to this one. The total output for this sector 2, which is this one, supposed to be equal to this one here.
What's the old formula for total input?
The total input here is equal to total output minus value added. Then the total output here is equal to final demand plus intermediate demand. And final demand is equal to total output minus intermediate demand. We give you the final demand.
So if you are not derived the final demand, how will you get total?
Now, if you don't have final demand, it means that you have total output. The expression only comes like that. If you don't have final demand, it means that you have total output. And if you have final demand, it means that you are supposed to look for total output. Yes, it's addition and subtraction. Okay, now, this one is intermediate demand. Let intermediate demand be R. Let final demand be F. Then total output be T. I've said that if you add intermediate demand with final demand, it will give you total output. It's just a way to interchange any of them. If this one is not given, you just if this one, if you are looking for intermediate demand is just equal to total output here, then this one will come this side minus final demand, it will give intermediate demand. If you are looking for final demand here, you just take intermediate demand this side. The final demand will be equal to total output minus intermediate demand. Just need to rearrange them. There is a part that explains that part. It's just going to be okay. Then the total input there, output is equal to plus A12 plus B1 is presenting. Then this one is A21 plus A22 plus B2.
Assuming that this total input must correspond to that total output.
Yes.
What if I have different?
That's why I said input output. First assumption says that the proportion of input is equal to the proportion of output. So for you to get the whole of this now is the input output table, which is the component of input output analysis. Then for you to get a technical coefficient, the technical coefficient is another part, and it's very important. For you to get a technical coefficient, for you to find the technical coefficient for matrix A. Now, you will have a particular number here. When we take an example after, you have a particular number here. Now, for you to find the technical coefficient for this number, the technical coefficient now, technical coefficient. For A1, 1. This thing means that unit of output in sector 1 used as input in sector 1. That is why it is A11. This one means unit of output in sector 1 used as input in sector 2. This one is unit of output because you must have input before you use the input as input in another one. This one is unit of output in sector 2 used as input in sector 1. That is what now like this you are having, when you add this you have total input as coming down. Now when you add like this you have output. That is unit of output in sector 2 used as input in sector 1. So for you to find the technical coefficient for this, you pick this number here, A11, then divide by the total output that sector. The final demand. Sorry, the total is the total output. The total output. Let's say the total output will be which sector can we use? S1, S2. Total output. Not final demand, total output. Then, if you are considering this one, when you want to find the technical coefficient, when you are picking each and every value on this sector 1, you pick this one and divide by the total output in sector 1. You pick this one, divide by the total output in sector 1, because all of them are on sector 1. When you come to this one, you pick this one, divide by this one is sector 2. This is sector 2. You pick this one and divide by the total output in sector 2. You pick this one, divide by the total output in sector 2. That's how you find the technical coefficient.
So it goes like that. If you have other,
if you have sector 3, yes. That is for you to get a technical coefficient. This is sector 1, sector 2. Everything here divided by the total output in sector 1. Everything here divided by the total output in sector 2 will give you the technical coefficient. Then it is from there that, because the technical coefficient is for matrix A, it is from there that you proceed to get the Leontief matrix, which the Leontief matrix is the identity matrix minus A. So the identity matrix now depends on the number of sectors you have. If you have 2 sectors, that is X and Y, or X1, X2. If you have 3 sectors, that is for a 3 by 3 matrix, then you form the identity matrix and you solve. In the identity matrix, let's assume that you have a technical coefficient in this order. You have, let's say you have A11, A12, A21, A22. The technical coefficient. For you to form a Leontief matrix, the identity matrix will be 0, 0, 1. Then this is our A. Then our I minus A now will be equal to this matrix minus this matrix. That is 1, 0, 0, 1. Standing for I. This I. Then this minus. Then this A. This one. And we have A11, A12. Then we have A21, A22. After here we use numbers to be more clear.
No, I understand, but I just want to know.
This one here, what we are looking for is a Leontief. When you subtract the technical coefficient matrix from the identity matrix, the matrix that you have is the Leontief matrix. Now, the Leontief matrix is the identity matrix minus the technical coefficient matrix. Now, this is the identity matrix minus, look at this minus here. Then this A, the matrix of technical coefficient. Then for subtraction of matrices to whole, the rows and columns of the 2 matrices must be equal. This one is 2 rows, 2 columns, 2 rows, 2 columns. So we can subtract. That is why I say that this one minus this, you write the answer. 0 minus this, you write the answer. 0 minus this, you write the answer. 1 minus this, you write the answer. Then you have a Leontief matrix. Then after getting a Leontief matrix, Then the next part is the Leontief inverse. The Leontief inverse is just the inverse of this one, which is the identity matrix minus A raised to the negative 1. Then you find the inverse of this one.
So that means this relative now, we will not change it to, we will not find the determinant, we will just minus it like normal minusing of matrix.
Yes, you find it because you find the determinant, because for you to get the inverse, you must first of all find the determinant. Then I'm just trying to explain the components of this input output. Because before you even get the inverse, that inverse, you must get the determinant first. You must get the determinant of that matrix before you find the inverse. But in general terms, you have to get the inverse of that relative matrix. Then you must get it through by following the process of finding determinant.
Let's use figures.
Sticky. Don't kill it.
So now let's consider the Leontief model. The Leontief model now, you are playing this one. The Leontief model is what will take us to the foundation of this word that we saw now. Now the Leontief model explains the total production that is being determined by the intermediate demand and the final demand. According to the Leontief model, we say that let X represent the total output slash the gross output, and let A represent a technical coefficient. Then let AX represent the intermediate demand. Then I don't know that he used D to represent final demand with F. That will just put it in for me. It's D or F. So D is the final demand. No, we established something earlier that for you to get a total output is a sum of the intermediate demand and the what? Final demand. Now we are going to use that here. Total output here is X. is equal to the sum of the intermediate demand and the what? Final demand. And now the intermediate demand here is AX. AX plus the final demand here, which is D, to give us the total output of the gross output. Now, we are going to rearrange this thing so that this AX will cross the left hand side and meet X. We have X on the left hand side. AX will cross the left. We have A minus X. Then if AX crosses, what is left on the right hand side is just D, which is the final demand. When you want to proceed further, you discover that X and X are common. You factorize, you pick one X outside. You have X outside. X divided by X here, you have 1. Then you cancel X here, you have A is equal to D. Now, if you still want to make this X stand alone, it means that you must clear this 1 minus A. That is, you divide both sides. You have X is X into 1 minus A is equal to D. Divide this side by 1 minus A. Divide here by 1 minus A. So that this one will cancel this one. And you have X is equal to D over 1 minus A. And this D over 1 minus A can be written as the inverse of 1 minus A. Because this is the same as D times 1 over 1 minus A. So loss of indices states that if a number is if you have such a thing, you can take the inverse of that number. So that is 1 over 1 is the same as 1 minus A inverse, loss of indices. So in place of this 1 over 1 minus A, you can then you have X is equal to 1 minus A inverse then times D. Now, the Leontief model or the input-output analysis is based on this concept, this situation. That for you to get the total output that each sector will produce, given a finite demand, you must first of all find the Leontief matrix, take the inverse, then you multiply. You multiply the two matrices together, then you will have a total output that each sector or each industry will produce, given a finite demand.
This 1 minus A, is it the same thing as the identity matrix?
Yes.
1 minus A?
Yes.
So we use identity here.
Yes.
So that means when we find the determinant of this identity matrix, we get 1.
You get 1.
Is that what?
Yes. If you multiply a matrix or any number multiplied by its inverse is 1. Any number 1, or let's say 2 over 1, that is the inverse of 2 over 1. 1 over 2, you give us 1. So that is why now this one here is equal to I, which is the identity matrix. The next step is for me to just the next step is to say that the one here that I'm using is equal to identity matrix. That example that I solved in class will have you complete a full question.
Yes, very deep out.
Should I clean this one? Or you are still writing?
You can claim it.
Okay, should I clean it?
Yes. Okay. We'll do it, but,
No, no. So anytime you are asked to find the total output that each sector or each industry will produce, given a final demand, this is what you are supposed to get. You are supposed to solve to this point where you have the inverse of the Leontief metric. Then multiply the inverse with the final demand. Then you have a colorimetric that will give you the output for the sectors. For example 1.
The inputs of coefficient metric A and the final demand G, D vector from economy with 3 sectors are given below.
We saw with 3 sectors. You should know. Let's start with 2 sectors, then we move to 3 sectors.
Okay.
No question with 2 sectors.
In an economy, there are 2 industries.
2 industries.
A and B.
A and B.
And the following table give the supply and demand position of the industry. And it's a table. It's an A.
The table is in what form? Where is it in sectors or industries?
We just wrote production, A and B, A and B.
Okay, production like this.
Yes.
The other production we have A and B.
Yes, we have A and B. No, on the straight line. The B is down.
Okay, let me see the
You need to copy the question.
Yes, it's like you don't have question for me.
Say you cannot go there, the chopper finish. Say you cannot go there, the chopper finish.
You know, since they give you only zero. Some zero, some zero. It's a fish cooker. So I look, they won't do no boy.
So this one is 15. 10. 20. 30. The final demand. Final demand. Final demand here is 10. Here is 15. Total output. Total output here is 85. Here is 65. 15, 15, 10, 10, 5, 20, 20, 30, 15, 65. And you are required to determine the total output when the final demand changes to 12 for industry A and 18 for industry B. Finally,
This one does not have intermediate demand.
no,
We assume the
no, the intermediate demand is for here, this one production, which is 25.
okay.
Intermediate demand for this one.
Do we
No, we don't need to form the table.
we don't perform.
Yes, the question does not demand us to form the table. The question just says you are required to determine the total output. Yes, the total output. If the final demand changes to 12 for industry A and 18 for industry B. So these ones here are industries. These are industries.
You are required to determine the final demand.
Yes, you are required to determine the total output.
Total output.
Yes. If the final demand changes to 12 for industry A You are required.
Uh-huh.
I should write to this.
Yes.
Okay. Yeah. Okay. You are required. I can just say determine. Determine the total output. Total output. If the final demand changes to 12 for industry A. For industry A and 18 for industry B. Determine the final demand. Determine the final. Determine the total output if the final demand changes to 12 for industry A and 18 for industry B. But if you look at this table, I don't think we can get the final demand without solving it. Because in this table, the final demand is 10 for industry A. The final demand for industry B is 15. Then the total output for industry B is 65. Here is 35. May they say that now there are changes in the final demand. The final demand here is no longer 10, it's 12. The final demand here is no longer 18. Then the total output too is supposed to change. Then is it sensible to just change the final demand there, then you get the total output? I don't know whether that one is correct because I have not tried it in that way. I don't know that people are reasoning the same way they are reasoning. Because if you change this one from 10 to 12, then if you add everything, you have a different total output. If you change this one from 15 to 18, you add everything, you have a different total output. That is how some persons will solve and they will say it's simple. But what you are looking for is total output, and we are going to apply this S is for total output. So we are going to solve in such a way that we will get this thing. This one now is the final demand. And the final demand that we're using to solve this question is 12 and 18. So we already have the final demand as 12 and 18. So what you are looking for, you are going to solve till we have this thing. Then you multiply the two of them together. Then you get the total output.
Please walk I'm not following this.
Okay, you're not following. But just, okay, in all that we are doing here, just understand that anytime you are being asked to find the total output, this is what you are going to do. Just state this one. That for you to find the total output, you must first of all have the final demand. And you must first of all solve in a particular point that you have this inverse. And when you multiply the two of them, you have total output. So now, the first thing is for us to get matrix A.
Yes.
Is to get matrix A solution. Find A. And this A is a technical coefficient. A is a technical coefficient. Now, matrix A is equal to, this is for sector A, for industry A.
Yes.
Industry B. You pick all the numbers on industry A and divide by the total output for industry A. This is industry A. The total output is this. You pick this one, divide by this, this one divided by this, because all of them are on A. The total of A is this one. You pick everything here, which is for B, divide by the total of B, which is this one, to get matrix A. That is the first thing. Now, you pick 15, divide by 35. You pick 20, divide by 35. You are done with this column. To this column, you pick 10, divide by what? 65. You pick 30, divide by 65. Now, if you are good with fractions, you proceed with fractions. And if you are not good with fractions, you just divide it and write the numbers in decimal. Decimal, right? So, if it is in decimal, you use 2 decimal places. After this, you pick 2 digits. Then divide this one, let's say 15 divided by 35. 0.4.
So 2 decimal places.
Let me use. That is
So 2 decimal places.
yes. After the decimal point, pick 2 digits.
43.
Okay. 15 divided by 35 is what?
0.428%. That's 43.
0.43. Then 20 divided by 35.
0.57.
0.57. Then 10 divided by 65.
0.15.
0.15. Then 30 divided by 65.
0.46.
0.46. So this one is the matrix of technical coefficient. So the next is to get a Leontief matrix, which is I minus A.
I really want you to see how you do this in fraction, because
Okay, here is fraction.
fraction, yes. So it was somehow confusing.
The fraction is the same thing now.
It's the same thing. This one is easy. It's
Which calculator are you using?
It's scientific calculator.
You can use fractions too. Okay, you prefer using fractions.
I prefer fractions though. I
Fractions.
just want to see how this one will be it will go. Fraction now.
Where is the one for fraction?
Anyways, let's do it. Let's do
You can
it.
change it to fractions. in the
Well, I
calculator.
don't find it.
You can
You can change it now. You don't know how to change it. Let me show you. You can change it. This one now, you will just press. You will just press this here, this key.
what's the name?
You have A, B slash C. If you use this calculator, this one I use it.
That's you.
Okay,
Yes.
3 over 5 over 6. So that's what we do. 3 over 7.
Yes, 3/7.
This is-
Yes, 3 over 7.
You just change it like that.
I don't know 6.
Let me see that thing. No, it's not appearing on this one. This very one.
Okay, this one is not. It's not cashew now.
It's not cashew.
One is Popo. That one, that calculator will be used.
You can. Then you have. No, you have. You
You
buy
have
this
to
one.
get cashew.
You buy this one.
I will get calculation.
Only you have this calculator.
I will get one.
Okay.
If I get
Well, borrow you that day. You write to come and use it back. Because after the exam, you still be using the calculator. What is that?
Okay, we'll do this one again. We'll do that brief.
Let's do
that
that.
fraction now.
Let's
Okay, now you understand how to get this. Now you can get the technical coefficient.
Yes.
When you have the table,
Yes.
you can derive the technical coefficient.
Yes. Okay, that's it's like the way they sit down for us. Now, how they get this? Make them sit down for us. Like, I know. Because some they do like this, I make you understand how.
So now,
Make I act it.
find I minus A. Our I now is identity matrix, and this matrix here, this matrix is a 2x2 matrix. So we are going to form an identity matrix for 2 by 2. Here is 1, 0, 0, 1. We already have A. So I minus A is equal to this matrix is for A. This one is for I. Then you open a bracket here. Is I before A? The first element here is 1 back, standing for I back, minus the first element here, which is 0.43. This one, 0 back, minus the second element here, 0.15. 0 minus this element, 0.57. 1 minus this element, 0.46. If you use your calculator, I minus A is not equal to what? 0.57.
Okay, so that's
This one is 0.57. 0.57. This one is 0. What?
So that one is minus 0.57. The down is 0. The down is 0 minus 0. 0 minus. It's minus. Now you just put the minus.
Yes, minus what?
Minus 0.57.
0
Minus
57.
This one and this one is the same answer.
That's what is coming out of you.
Yes.
It's the same answer.
0
This one is that one. The top is plus. This one down is minus.
That's how the answer is coming.
Yes,
Minus
that's
0.57.
Then this one is what? Minus 0.15. Back.
No, 0.
This one minus 0.15.
Yes, minus 0.15. Yes.
Then this one
That's
0.54.
0.54. Yes.
Any discrepancy? You have different answer. If any of this is wrong, then what you do that is also wrong. You have to be very careful. At this point, you have to be very careful. Then move. Each and every step is very important. Because if you make a mistake here, everything that we solve down waste time is wrong. So the points are very important. So now this is the Leontief matrix. Now the next step is to find the inverse of this matrix. To find this. Because we are heading to this point. We are heading to a point where you have x is equal to I minus A inverse times D. We started with this part. Now we have I minus A. Now it's to us to get the inverse. Then you multiply by D. Now to get the inverse of this matrix, the inverse of a matrix, the inverse, this is inverse. Inverse of I minus A. That's the meaning. Now the inverse of this matrix, which is a Leontief matrix, the inverse of any matrix at all, the inverse of any matrix is equal to 1 over the determinant of that matrix. Like this is determinant. When you have a slash, it's determinant. Then times the adjoint of that matrix. This is the formula for finding the inverse of the matrix. For you to find the inverse of the matrix, any matrix at all, whether 2 by 2 or 3 by 3, you must first of all find the determinant of that matrix and keep. Then you proceed and find the adjoint of that matrix. Okay. After finding the determinant and the adjoint, you divide them or you multiply by 1 over the determinant. Because 1 over the determinant is descendants. This thing is descendants. or I minus A raised to negative 1 is equal to I minus A adjoint. Then divide by the determinant. It's the same thing.
Yes.
It's the same thing. So for you to get the inverse of this matrix, step 1 is to find the what? The determinant. After finding the determinant, you find the adjoint. After finding the adjoint, you multiply them together by 1 or the determinant, so you divide by the determinant.
This is just one question.
So,
One question.
yes, this is one.
That would be anyway.
No,
Because
you don't
I
understand.
use grammar
You know,
Okay, you use Cramer's rule.
using grammar rule.
You don't understand what I talk. Just one question.
So I don't know,
You have
maybe
to-
when we are done with this one, we'll use that fraction to use this grammar rule. Fraction. There are a lot of things that are confusing me.
This one I did not teach you plenty things. Maybe he will bring. This one is matrix invention. Then Cramer's rule.
Actually not explain these things. Don't come and be solving these things.
So we can, in order to find the determinant. Now we'll find the determinant now.
This place is not clean.
This one is found now. Somebody is found
It's how we clean out when we get to this age.
That's how we use it.
Look this side.
So the determinant of, we first of all find the determinant of I minus A is equal to. This is I minus A matrix. And this is a 2 by 2 matrix. So the determinant of a 2 by 2 matrix is you multiply the element of the major diagonal. This times this minus this times this.
Even though they are the same. Okay, when they are the same is
They must be the same. If they are not the same, they will be half. Like what?
I think you have the same value, like 0 and 1 when they are arranged in that diagonal. Since like from the start, find E minus from the start. So I was thinking maybe this 57 should have been where this other 54 is. So that we have a uniform or the same values.
No, the value was just gotten from here. The value was
No, I know, I understand. Or looking at when you are doing that this thing, I was thinking about you need to have that this thing. Is it calculator?
No, me too. So you follow up to that point?
Yes. It's not as if we just wrote the figures there.
Me, I know they didn't just write the figures. What I'm saying is they have to be. I was thinking maybe they have to be the same.
That's
That's the same value.
I don't share them.
they are the same value.
Here right now, as this one, they will know.
Okay.
57, 54. Okay. So let's see how it goes.
Let's work it first. We will know whether the figures are wrong or not.
Let's see how it goes.
The figures were not just put there. Because the way you talk about, I say we can just change it and put another figure, another set of figures there.
Me, I was thinking maybe from the mass we're supposed to have a uniform.
No.
This thing from the calculator.
No.
Okay, uniform in terms of okay now just try solving for the determinant. Let's see. Yeah.
Okay, 0.57 minus
0.57
minus
times
okay times
0.54. You write the number. Then minus. Try solving the lesson.
okay to solve. I'm not having calculator. 0.57 times 0.54.
0.2223.
0.5 0.57 times this one. Write the number here. Then minus. These numbers still are having negative, but you
Yes,
take
they
negative.
will not become
But they
positive.
will not become positive.
The answer is 0.2223.
0.22.
This one get what? 0.5.
Which was
0.5.
0.3078.
Okay.
0.3078. Five point five seven times 0.5. You get 0.378. Then you minus it from the answer of the number.
Now you're working the terminal.
Yes.
This time.
The determinant is what? So it's
0.22.
0.2.
Is that a code that I want to
But
you multiply this and then this.
Okay, the determinant for 2 by 2 meters and this one times this times this. And you have 0.57 times this one, 0.54, then minus. Like if you multiply negative and negative is positive. Then okay, now you have negative 0.57 times negative 0.15. And this one is what?
0.3078. 0.3078.
0.3078. Yeah, minus what?
0.0855.
0.0855. Then the determinant is equal to what? You subtract the two of them, you have
0.2223.
0.2223, right?
222.
Okay, two in 3 places.
Yes.
You cannot approximate. There's no.
Let's just use 2 decimal places. So the determinant that he got when he was solving, is it the same as this one?
0.22. No.
His determinant is what?
This is Cramer's rule.
That's okay.
Okay.
You use Cramer's rule.
Cramer's rule 2, Cramer's
You use Cramer's rule.
Cramer's rule 2 is supposed to have determinant.
Let's finish this one. Let's finish this one. We can.
And that's why I said, let's do this one.
Yes, let's do this one.
Let's do this one.
Okay, so after getting
Because I know exactly that something you say using Cramer's rule.
after getting the determinant, we are going to look for the adjoint. The adjoint,
The inverse.
which is the inverse. Now, after getting the adjoint, you divide the adjoint by the determinant, then you have the inverse. So now the adjoint of the 2 by 2 matrix, like this, find the adjoint of this matrix is equal to. Look at the matrix here. This is the matrix. You interchange the elements from the major diagonal. That is, this one will come here, this one will come down.
Yes.
You have 0.54, 0.57. then this other element, you multiply them, it's negative.
Yes.
That is this one that is negative. This one that is
So,
negative.
okay.
So they will now be positive 0.57, 0.15.
That's the adjoint.
That's
You now find the determinant of this. Right? That's the adjoint.
No, yes, that's the adjoint for two
That's
dimensional
yours.
matrix.
So that means
You
you just
don't
need
find
to
it.
change.
You don't find the determinant.
No. We are looking for inverse.
Yes.
And to find inverse, you first of all get determinant. You are getting the determinant.
What I mean is, after getting this like this now, would you use it? Would you apply it straight into
Yes,
the
after
equation?
getting it like this, you just apply it straight here. Because this is the adjoint of this matrix. Look at the part here. Now we are getting the part to be this.
Why did you change that?
Because the other side is negative, that remain constant, will not interchange it.
There is a long way of doing this thing. This one is just shortcut. The long way of doing it to you get the same thing, but for let's do the long one for 3 by 3 matrix. Because the 3 by 3 matrix don't have this shortcut. They will follow, I will show you the normal one. But the adjoint of 2 by 2 matrix, this is the matrix. You just interchange this one. Interchange this one. Then multiply this one with negative. Because the normal way, you take transpose.
Exactly. I was waiting for.
Because if you take transpose of a matrix 2, the element on the major diagonal always remains the same. I don't know whether you understand the thing. Even if you take transpose of this matrix, this one will still remain the same. It will not change. Let's try it like this. If you take transpose of this matrix, that is, this is a row. This one is a row. Transpose means interchange the rows with columns.
Yes.
So now, if we interchange this row, this is row 1 to be column 1. You have 0.57. This one now you have minus 0.15. The first row is now the first column. The second row here will be negative 0.57, 0.54.
That's transpose.
And look at the transpose. The element on this major diagonal, they are still the same. That is trying to take transpose. But the long way of doing this thing is to take cofactors. You take cofactors.
That one is 3 by 3.
You can do it on this one too. You can do it on this one. But this is the adjoint, so you put or you don't want to follow like this. Now the adjoint, you take cofactors. Now cofactors are called minors. You cancel this row. You cancel this column. If you cancel this row and you cancel this column, it's only 0.54 that will remain. 0.54. You cancel this one and this one. So the intersection is here. You put the number that is remaining here. So when you cancel this one, you say row 1, and you cancel column 2. The intersection is here. What is remaining is this. Minus 0.57. Now, you come to row 2. You cancel the first column. You cancel row 2. What is remaining? Minus 0.15. And the intersection is here. You bring it here. Minus 0.15. You cancel this row. You cancel this column. What is remaining? 0.57. Now, there is
cofactor now.
Yes, these are the cofactors.
Okay.
Now, there is a matrix that is called sine theta matrix. The matrix is plus, minus. Here is plus, right? So it's minus, plus. This positive is for this one. Negative. You change to positive. Now, what we have is this. This one is positive. You have 0.54. This one is negative. Times negative. So now you have 0.57. This one is negative. Times this negative. So now you have 0.15. Positive, positive. 0.57. Then you transpose. If you transpose this one, this row, it becomes the first column, which will be 0.54, 0.57. This second row here will be the second column, which is 0.15, 0.57. It's the same with what we have, the same with this one. They are the same.
Let's take the short journey for now. Not good because at least I've still remember something that on my graduate days.
For 3 by 3 days, that shortcut. There is no shortcut.
For 3 by 3 days, you have to go
3 by 3.
Yes.
Yes, for 3 by 3, you must have to find cofactors. Find cofactors, multiply by that plus minus plus. Then you transpose. Before you get the adjoint.
One question.
Voila.
So, but for this 2 by 2, let's use that shortcut. For 2 by 2, once you want to get the adjoint for 2 by 2, just interchange the element on the major diagonal. Then multiply these ones by negative. Finish. So to get, actually this one, you copy one.
Leave that one, leave that one, leave that one.
I should clean it.
Leave it for this one. Leave that one.
I don't know. A minus 1 minus I minus. Then now we are getting to the inverse proper. Now the inverse of this matrix is now equal to 1 over the determinant of this matrix adjoint of this matrix. Now we have gotten everything. We have the adjoint. Let's use this number to 4 decimal places and do something. Subtract this one, give it to 4 decimal places.
2, 2, 2, 3.
2, 2, 3, right? So now we have 1 here over the determinant. This is the determinant. 0.2223. The adjoint is this 0.54, 0.15, 0.57, 0.57. So there are 2 ways of doing it. You can either say 0.54 divided by this one divided by this one, this one divided by this one, this one divided by this one. It's the same thing. Or you divide it 1 divided by this, then multiply with everything inside. There are 2 ways of doing it too. You can either say that 0.54 divided by 0.2223, 0.15 divided by 0.223, 0.57 divided by 0.2223, 0.57 divided by 0.2223. Any of them. Or you say 1 divided by this, it will give you the answer. Then you use that to multiply it by this, multiply by this, multiply by this, multiply by this, you still have the same thing. This calculator. Stop sharing.
0.54 divided by 0.2223, you have 2.43. You approximate it. The other one is 9. So round it up. I wanted to sound like a word.
Okay, so it's now.
Don't worry, it's fine.
Okay, this one is what?
2.429. 2.43. Except, how many decimal places do you want to give?
Let's use 2.
Okay.
0.54 divided by
2.43.
2.
2.43. And the other one is 0.15 divided by
0.15 divided by 0.223.
0.67.
675.
0.675.
No,
67 is 3 decimal places. Is it not 3 decimal?
it's 6. That other digit that is there is 4 now. 4 is rounding down.
4, 8.
Is it this one?
0.8.
Yes, yes.
0.6758 divided by 0.2223. Okay, wait. It's 0.6747. So it's 4 that is there now. 4 is not rounded down. 4 is rounded down. Let me see.
If you round that one to 5, then it will be 1. Then you have it to
0.15
5.
divided by
It's
0.223.
actually, let's take 0.67.
This is 4 now. How can you round?
It cannot.
This comma that you're using as
It's comma that is used.
Okay, it's the same thing.
But it's the same thing.
Okay, 0.67.
0.67. 0.57 divided by 0.223. 2.56.
2.56.
Yes.
2.56. Yeah, 2.56.
0.57.
Same thing.
Yeah. It's 2.8.
So this one is the inverse of the Leontief matrix. The inverse. The inverse. So now, the total output is equal to the inverse of this matrix times D. And they say that our D now for industry A is 12, huh? And industry B is 18. So this is the matrix. So now we are using this matrix and this one together as multiplication. This is the rule. For you to get the total output, you must first of all get the inverse. Then multiply the inverse with the total demand, the final demand. And this is the final demand. This 12 is for industry A, 18 industry B. Then multiply this matrix with this matrix. We have S is not equal to
12 times
2.43, 2.56, 0.67, 2.56. Then times this matrix, 12 by 18. Now the rule for matrix multiplication is the columns of the first matrix must be equal to the rows of the second matrix. Here, this is the first matrix. This one is the second matrix. And the columns of this one must be equal to the rows of this one for multiplication to take place. The columns of this one are 2 columns. The rows of this one are 2 rows. Row 1, row 2. So you can multiply. So now the multiplication is row times column. Row times this column. This row times this column. That is
It
multiplication.
become one matrix.
become one matrix. So now, this rule, the first number here is 2.343 times the first number here, 12, then plus. The second number here, 0.67 times the second number here, 18. We are done with this row, that is this column. Then this row, that is this column. The first number here, 2.56, times the first number here, 12. Plus the second number here, 2.56, times the second number here, 18.
Please, before you show me, let me know.
Yeah, this is very smart. Let's get the answer then, right? This is one, instead of it to make it longer, you just write it as it is like this on calculator. You just open bracket, write the multiplication, close bracket, plus. Open bracket, write the multiplication.
29.16 for the first one.
For the first answer here,
Yes.
29.16.
16. So the other one is 12.06.
12.06.
Yes.
To correspond with the answer you got using
Well,
parameters.
I've not multiplied the down one for the first one. Okay, I should do it once.
You cannot be on computer like that. You can. You know. Okay. You just do it like this so that you not waste time.
Open bracket. 2.43.
Go bracket. Go yeah.
Then show me that one. Show me that one. Show me that one. Show
Which
me.
one?
No, this one where you dey do close bracket, open bracket. Show me a bit. I don't go back calculator. I don't know why they use them.
2.4.
Never do it before.
There's 2.43, ba?
41.22.
Times 12.
How did you get the photo? How did you go to open bracket?
Bracket.
Yeah.
2.56.
Eh?
Yes.
No. I will first of all press open bracket first.
Yes. Then you write
2.43
2.43 times 12. Then you close. You close bracket.
Close
Then
bracket.
plus.
Plus.
Open bracket again.
Open bracket.
0.67
0.18.
times 18. You close bracket again. You know answer more.
Shanda.
Guna,
Shanda.
You
See, I
have
buy calculator. I don't know why they use
for
that.
correspondent.
Hey, she didn't know Shamiga.
Hey.
I
I go buy calculator. I don't know how they use that. Give myself problem. Eh?
You have 41.22.
41.22. Kai. So this thing just did the calculator. I don't know what it is.
You do the same thing with this one.
Eh?
I do the second one.
I want to
The
understand.
second one give us answer.
You have one minute. You can try it.
No,
now.
2.5. The other one.
No
The
worry
second one
yourself.
give answer now.
The answer. Wait, you that. So.
Okay, this is all.
5, 6, times 12, plus.
This one we use grammar school and we use this fractions.
5, 6,
Okay, give us answer.
1,
76.8.
bracket
76.8.
That's
Just
only
one.
76.8.
Just go buy calculator. I don't know what those functions there for. In all my life, I've never used those functions before. In all my life. Eh?
76.8.
Which one is this one?
The second one.
The second one,
76.
yes.
8.
So the total output for
So we just say the total output for A is, say A is 41.22 and total output for B, industry B is 76.8.
Given that the final demand for industry A is 12 and for industry
B
Is 18. So what if you just, without solving this one, you just pick this 12 and fix there?
we get the same thing. I don't think we get the
We
same
will not
thing.
get the same thing.
Because if you put 12 there, 12 plus 10, 22. And 22 plus 15. That's 37. It's not the same.
Hey, wahala dey o. Remember?
This one is no long.
Eh?
It's like you are not doing microeconomics. You're not doing
No,
microeconomics.
it's not.
No, our micro is not stressful like this one. No. Our
The
micro
second
doesn't have
example I
even
saw
mass.
is for 2 by 2 or 3 by 3.
The what?
The second example that I saw is for 2 by 2 or 3 by 2.
This
Or
one
3 by 2.
is for.
It's grammar school.
This one is for 3 by 3. 1 to 3. But it's this one that he used grammar school for this 2 by 2.
The grammar
I think
school
both
too.
of-
The grammar school does not involve finding a
This one is relative method.
Let's just solve it again using that grammar school. and using
Grammar school,
fraction.
he solved for Leonti matrix. He solved for I minus A.
Oh, you know it's solved for I minus A.
He just used the technical coefficient. No?
Not solved for I minus
He used the technical coefficient instead.
Why is it difficult for them to just do it?
Where is this 16 coming from?
Give you something simple. Doesn't make life simple.
They go
It's
for
when
the
you find it
exam.
hard, it's not important.
16 here, I make 18.
Let's use Aki's examples. Anyone come to manage the struggle
I'll
with
very
the
complicated.
Go to this one. Go to this one for us.
Here the coefficient, here the fraction.
Yes. And this side, I don't know how we did this. That's why I am confused. Why it has been confusing. That's why I wanted. This is the main thing I was coming to ask because I don't understand how we did those fractions using grammar school.
This one here. This input is 1 5. This one is 1 8. It's important. Which one? It's always important. Like the paper in textbook.
Okay, they do the photocopy or photo. I need to do that photocopy.
Okay, this is super part.
Let's use the fraction.
We'll do this one.
Sam, you're using fraction. Let me have that calculator so that
Yeah.
fast.
You change it to fraction, then give me the answer.
Is it that you want to do fraction of this same
Using grammar school.
grammar school?
Yes, yeah.
Now the technical coefficient that we have here are these. These are the technical coefficient. So the final demand that we have are 12 and 18. So this is what we are following here. Now this x now, we have x1 and x2. Then for x1, which is the total output for industry A, is this x is now in two places, x1 and x2, because we have industry A and industry B, is not equal to the technical coefficient. This is for x1, this is for x2. So now this one here now, this one here is for x1, this one here is for x2, this one here is for x1, this one here is for x2. So each and every industry must combine x1 and x2, x1 and x2. So what we have here is this one, the total output, which is x, look at this equal to, is equal to technical coefficient here is 3/7 x1 plus 2/13 x2.
This is grammar school.
Yes, this is
Yes.
the process of using grammar. Then plus the final demand, the final demand for
Which is 12.
which is 12.
Oh,
Is 12.
understanding better.
Then this one now, grammar school now you will have equations. So
Yes.
you have equation 1 and 2 for you to use grammar school. You don't have to go through this process. Now this one will give us equation 1 if you arrange it very well. If you arrange it very well, if you want the x to be on this side, then you have to take x1, this one to this side now, it will be 3/7 x1. This one will become this side, it will be minus 12/13 x2, then equal to 12.
Hold on, please. Let me get this thing. I want to get something. I'm lost. I'm looking for myself like this.
You two are confused.
I want to understand what you are doing. I want to really understand. You applying this formula up here.
This one.
Yes. Okay, so now this is A.
These are the A's, the technical coefficients.
So this A now, you now expanded it by multiplying by x1 and x2.
X1 and X2.
Okay, so when you multiplied x1, you got 4 up.
This one here.
That's 3 over 7 x1,
Yes.
2 over 13,
2 over 13
plus the 12 that was given.
Plus the 12 for industry A.
Yes, for
Because
industry.
this 12 here is the final demand.
Yes, final demand, yes. For x2, this is okay, this is x1 we're still doing, we've not done
Yes,
this.
this is for X1.
Okay.
Now X1 will give us equation 1.
Okay.
So now this one here is 1. Namsa, this one is 1.
Yes.
1x1 minus 3 over 7 x1. So this is 1 minus 3 over 7. Since we are using fraction. And it's x1, you can subtract them. And the coefficient here is 1. That is 1 minus 12. So this one is over 1. Now you can do, for you to do this thing, you multiply here by 7. So it becomes 7, right?
Yes.
Here too it becomes 7. Then you have 4 over 7.
Is that why they have 4 over 7?
It's fraction simplification now. Because you have 1 minus 3 over 7.
Yes, 7 denominator. The same is the LCM now.
Yes, you multiply here by 1, here by 1.
So, here by 7.
Here is 7. Here you multiply here by 7, here 2 by 7. So that the denominators will be equal. Here you have 7 minus 3. Here 7. Here 7 now. The denominators are equal to just pick 1. You have 7 minus 3 up. Here is 7 down. This one will give us 4. You can use calculator too, it will give you, then you change it to fraction.
Okay. I understand this step.
Oh, I know you have one.
Sam. Okay, follow on.
Hold on, just small.
So each one here is 4 over 7 x1 minus 2 over 13 x2 is equal to 12, equation 1. You do the same thing with this one. This x2 is equal to.
Why did x2 come in again?
Is it for industry 1 and 2 now?
Industry 1 and 2 now. For grammar school, you must have 2 equations. These things are not equations here to.
No, I don't understand again.
Sit down up.
I was getting it before.
Okay.
I was getting it before. Okay, you use x1 to multiply 3 over 7, x2 to multiply 2 over 13. For the equation 1. Then equation 2 now you use x1 to multiply 4 over 7,
Yes.
and x2 to multiply 6 over
13. That's how they are going to do it.
That's why I see that.
Okay, so now you have 4 over 7 times x1 plus 6 over 13 times x2, then plus the final demand, which is 18. I could take everything to the left hand side, we have x2 minus 4 over 7
Please
x1.
pause. Sorry, I'm taking you back. That first equation, that first one, you say x1 is equals to.
Yes,
This is supposed to be x1.
yes. It's supposed to be x1 for industry A.
For industry A. So for x2 for industry B now.
Industry B.
Okay,
Then here you have minus 6 over 13 x2 is equal to 18. Then what you use here is 1 x2 minus 6 over 13 x2 is the same as 1 minus 6 over 13. Then it will be 13 minus 6 over 13 which is what?
That's 7 over
7
13.
7 over 13. So here we have minus 4x1 over 7 plus 7 over 13x2
So equals to 18. Equation is over.
equation 2.
Pause, pause. Just wait. No, right.
Okay. Equates the equation. Then you get everything.
And we want to free talk.
Atau juga micro kan yang yang.
This method,
Mm.
this method, not carrying.
Yeah. Continue. So now we have equation 1 and 2. Then we solve by Cramer's rule. Now Cramer's rule.
Sorry, sir. The way, okay, it's the same thing he did, but then.
No, leave is where he's did it for. Leave
Yes,
it
yes.
for. Leave
Don't
it
talk,
for.
let it go.
Wait. But then what he did is, you see the way you substituted equation 1, and then the way you express it from x2 equals to 4 over 7x1 plus 6 over 13x2 plus 18. He now named that one equation 2. So he made it in 4 equations. As he made 4 different equations out of it.
Which one? Okay, which one is this equation 1? Let me see it here.
Okay. Equation 1, 2, 3, 4. So from Henry Jema, he named it equation 1.
But he did not solve equation 1 now. He solved equations 3 and 4. You see?
It's just this one and this one.
Yes, he solved equation 3 and 4.
Okay. It's the same thing.
That's why I said leave it for.
No, but I wanted to know why
Doesn't understand.
he named it like this, you know. And he only expressed these two. So why will he do this without expressing them and then just.
No, these ones are not having. That's why you're supposed to arrange it in such a way that you have matrix of coefficients different, matrix of variables different, matrix of constant. But here now, if you want to name this one, wait, is it here? You want to name this one equation 1 now. This one the matrix of constant.
Okay.
Constant are the answers. The answers here are the constant. This one is matrix of constant. Constant because they don't have any letter attached to them. But this one now is not a constant. This one is a variable. There is no need to name that one because this x1 is standing for a particular number that when we solve this thing we will get at the end. So it's not a constant. So you see Cramer's rule. We have to get matrix of coefficient. Matrix of coefficient. This is equation 1, equation 2. The first number here is 4 over 7. The second number here is minus 2 over 13. The third number here is what? 1 over.
Minus 4 over 7.
Okay, yes, minus 4 over 7. This is 4 over 7 minus 2 over 13. Here is minus 4 over 7. Here is plus what? 7 over 18. Now, here is x1, here is x2. If you multiply all of them together, you are supposed to have the final answers of 12 and 18 as the final demand. And it's at the end, after solving everything, you're supposed to have a final demand of 12. Final demand of 18 for the other three. One and
Okay, so what we were just trying to do with this one that we did was to develop the matrix.
yes. To find the equation so that we can guess the matrices from the equations. So now grammar school, now this one here is matrix A. This one is matrix X. This one is matrix D. So now grammar school now involves finding the determinant of this matrix. First, this is the original matrix. Find the determinant of this one. And the determinant of matrix A is like this. Determinant of matrix A is equal to, since it is a 2 by 2 matrix, this one times this minus this times this. Look for the answer. Let's try. That's 4 over 7 times 7 over 18. Then minus. If you multiply negative and negative, it's positive.
Yes.
That is 4 over 7 times 2 over 18. 4 over 7 times 2 over 18. This one we cancel this one.
Sorry. Why didn't we do that adjunct like we did the other one?
No, we
like
don't
change
need.
7
This is
to
grammar.
7 over.
That adjunct, we were doing it because we wanted to get inverse. Here we don't need inverse. So
Okay, we are using grammar.
we are using
so
grammar
the other
smart.
part. Okay.
No inverse.
I'll give 4 over 13.
Sir?
I'll give 4 over 13.
This one is 4 over
It's 4 over
13.
13.
That one is what? After we can write this one too on calculator, 4 over 7 times.
That's 8 over 81.
Only 4, you can do it on
Just give me
calculator.
that doing.
This one now, the fraction. Okay, this calculator is not having it. Okay.
Trouble don't go.
And this one is not having it.
So go. Can you calculate? Go. This one is
This
what?
one has
Casio, down to is Casio.
So why this one not having other?
Then you just multiply. But here now you have 4 over 18 minus. You
Minus 8 over 81.
You cannot cancel.
Yes.
So we
Minus
have
8 over
8
81.
by
Over
81.
91. I mean 81, sorry, 81.
Yes, it's 81. 7 times 3, that is 21. Right 1, it's 81. It's 91.
Is it 91 or 81?
Yes, 91. 18 times 7 is 91. So now we look for a way to solve this one further. Because this one is 91 already. So the LCN of 91 and 18 is what? The next thing to do. We have next year this
20 over 91.
20 over 91.
20 over 91.
Okay, 2 of them.
That's the solution of this one.
That's the solution. How do you get it so easily?
Sir?
How do you get it so easily?
This calculator now.
How did you
Okay,
go
okay,
about
let me
it?
check it. That is 4 divided
4
by
divided by 13.
18, close bracket, divide by, open bracket, 8 divided by 91, close bracket. That was your answer,
Say 20 over 91.
20 over 91. 20 over 91. Can you still lower that? Are you sure that's correct? Doubt if it is correct. Because 4 divided by 18 minus 8 divided by 91. So it's supposed to be 3 over 7.
3 over 7.
Sorry, 7 over 2. That's 3.5.
Wait, I come on.
Supposed to be 7/2, which is 3.5.
I read the whole question is wrong.
The FCN, the
No,
FCN.
I don't want to do that. I said, I know I can't say. What I'm saying is 4
Cancel.
divided by 13.
Where you put your device? Where you
No,
put
I
your-
don't want to say 4. I just say 4. I said 4 minus.
Now this one now,
Mm.
you put it in bracket.
Eh.
No, open bracket first. 4. Close bracket. Open bracket. Then 8 divided by 91. Close bracket. 20 over 91 still. The first one you got 20 over
It's
91.
20 over 91. 120 divided by 13. From the way, you know, Aki did it
So
different.
that kid too has 20 over
20 over
91.
91, but the way he multiplies it with his value,
Let's,
it's
let's,
12
let's
times
try it
7.
manually. Yeah, let me see something.
Yeah, the one that I say.
Okay, if you want to.
I still don't understand how.
But the LCM of 13 and
If
91.
you want to clean it, let me snap. That's
It's
it.
okay.
The LCM
You
of
can start-
91 and 13 is
okay.
91.
91, ba?
Yes.
So what will you multiply by 13 decided to have 91? 7.
Mm.
You have 7. 7 times 4 is what?
7 times 4 is 28.
28. So here is 28. Here is 91.
Mm.
Okay, it's 20 over 91.
Mm.
20 over 91. Have. Hiya. So the determinant here is 20 over 91.
I
So
don't understand this process.
you still don't understand?
I don't
Mr. Sam, what can we?
Because I was thinking maybe you multiply the value straight
This-
than how you
this
count
one is-
4 over 7.
This one is simplification of fractions. So
That's what I'm saying. I
This
was
one is
thinking
even simpler than
no.
the first
I
one.
was thinking maybe
And relative.
you multiply the values like 4 over 7 times 7 over 13. Like you
You
multiply
get the
4
same
you
thing.
still get the same thing.
Four.
You get the
times
same, you
13.
get the same thing.
and write the value, then multiply 7 by
You
7.
get the same thing.
You still get the same thing. That is, you say 4 times 7, but
No, 4 times 13.
No, no, why?
Okay, you multiply.
multiplication of fractions.
Denomination.
Numerator times numerator.
Uh-huh.
Denominator times denominator.
Yes,
That is multiplication of fractions. You multiply numerator together. Multiply the denominators together. If at all you don't have anything to cancel. And this one, 7 is here, 7 is here, it can be cancelled. I think we have 8 here. You will say it's 1 over 2. Because if you have 8 here and you have 4 here, you can say 4 into 8 1 time, 4 into 8 2 times. But you cannot cancel anything. Here you cannot cancel anything. 2 cannot go into 7 exactly without a remainder. And then we have 8 here, we can say that 2 cancel here 1 time, 2 here 4 times. And then this one is 12. We can say that 4 here 1 time, 4 here 3 times. That's what we do with multiplication. You can either multiply like this, or cancel like this, or cancel like that. So after getting the determinant, the next thing is
This way, this way.
Well, use
That's
this
right.
one. Yes.
so Cramer's rule. You have to find another determinant. This one here is the original determinant. This one. So for you form another matrix A x1.
Another matrix again.
Yes, another matrix. This one is the original coefficient matrix. This Cramer's rule that we are using like this, so you form another matrix for x1. This matrix now, you will replace this column here because this column here is standing for x1.
Next one, yes. With
This
12 and 18.
12 and 18.
Okay.
We finish and form another matrix for x2. that one, you will replace this column here with this one. Now, instead of this column, we have 12, 18, then minus 2,
over 13.
13,
7.
7, 13. Then you take the determinant of this one too. Take the determinant. Then you say we are going to find 3 determinants. Then we solve.
Let's do it.
So now, it's 12 times this. 12 times 7 over 13 minus negative 2 over 13 times 18. Determinant. 12 times this times that. So if you multiply this one together and divide by 7, 18 then this one you have what?
84 over 13.
24 over 13.
84 over 13.
12 times 7, 84. 84 over 18.
Minus 36 over 13.
So this one will give us positive.
Yes.
36 over 13. Now you have 84 plus 36 over 13. That is what?
120 over 13.
120 over 13 is the determinant of AX1. So now we form another matrix for AX2. Here we interchange this column. We have 4 over 7 minus 4 over 7, then 12, 18. 12, 18. Then we find the determinant. AX2 is now equal to 4 over 7 times 18 minus 12 times negative 4 over 7. This will give us what? 4 times 18, 72, divided by 7, plus 12 times 4, 48 divided by 7. This will give us 72 plus 48 divided by 7 plus 40. That is 72 plus 48 divided by 7 is 120 over 7. It's not too bad.
Okay, let's
It's the sun.
No, small thing.
Which is strong candle.
No, small thing.
This is 7.
No, small thing.
So now for us to get x1 and
One
x2,
question.
to get x1 now, the most important thing in this grammar school is to get the determinant. Now x1 is not equal to the determinant of ax1 divided by a1 by a.
Okay.
So the ax1, the determinant is 120 over 18. Then divide by the original determinant, which is 20 over 91. This is 120 over 13. Then times 91 over 20. What is the final answer? Then this one is x2 is equal to the determinant of ax2 divided by the original determinant. The determinant of ax2 is 120 over 7 divided by 20 over 91, which is 120 over 7 times 91 over 20.
120 divided by 120 divided by. Sam, do the math.
Come on, the right. 120 divided by that's 120 over 13 times that will be 7 times 7 20 That will give us 7. That will give us 60.
120 divided by
60,
13.
60 divided by 7. 60, 60.
Doesn't mean you're going to multiply
60 times 7.
Multiply
the up section.
The answer is 420.
420, right?
That's 60 times 7. Because 20 in 120 is 60. I mean 6. Is it 6 or 6? That's 42. 42.
Here,
Yeah.
1 time, here.
6.
Here, 1 time.
7.
Yes,
That's 42.
Then,
Almost the same thing. We got 41.22 in the former calculation.
So here is what?
Yeah. That would be
Here too is 1, right?
6. That would be 13. 13 times 6. 13 times 6. That's 18. That's 78.
78. Here we got what?
Yeah, we got 76. 70, we got 77.
27. Maybe it's based on the
Approximation.
In 40, 120 divided by 13.
So this
Kwabel.
Kwabel. Maybe tomorrow we consider the one with three variables.
Better. Let's go. Let's go.
Where is all the land?
If at all, I need to come.
Okay.
But if you can't come, don't worry, you understand. Don't worry, you don't have to come.
Okay, Kasanala. Okay.
Which one go to one? That's a you. Something can handle.
Sorry. The matter red now.
All right.
It's all red. Oh, God. What time tomorrow?
Should we make it by?
Mega. 120 over 13 remaining. This one. It counts for carrots. Look at 20 over 13 divided by 20 over 91.
Usugaga. We multiply 120 la. Okay, cancel my sheet 6 and 7. Then multiply.
Like this. Okay,
She 6 on 13 la. So 6 times.
Not that one. 120 over 13 divided by 20 over 91.
You call it Guma.
Okay.
Call it Guma 20.
Okay, yeah, I'm Zwami. Yes, I've got it.
Is that what time?
You should make it